friends, I'm Mrs. E. I'm so glad you joined me today again, and we have another lesson together. Well, let's get started. Let's take a look at the genre of myth. Learning target. Well, I will learn what are myths in literature. Success criteria. I can explain what myths are. I can read about gods and goddesses from the book, The Gods and Goddesses of Olympus. What are myths in literature? Myths are a type of literature, and a literature is a collection of written works. There are different kinds of literature, such as poetry, plays, novels, folktales, fables, and myths. And these are fiction. Myths are from cultures all over the world. Many myths, they date back to ancient times, which means they're from long, long ago. They are stories about how the world was created and why certain things happen. Today, the word myth is often used to describe something that is not true. But a myth is not just a made-up story. Myths tell of gods, heroes, and events that a group believes or at one time believed to be real. A culture's myths are often closely tied to its religion. Many myths date back to ancient times. The ancient Greeks also worshipped many gods. They believed that a group of major gods lived on Mount Olympus. The members of this group are often called the 12 Olympian gods. Some of the members changed over time, but Zeus was always the king of the gods. The book that we are going to read together is called The Gods and Goddesses of Olympus. We're going to read this book called The Gods and Goddesses of Olympus. It's a myth. Let's take a look at a few vocabulary words before we start. Ancient. Ancient, it means very old, relating to times long ago. Mortal. Mortal means not living forever or having to die someday. Well, here's another word, immortal. As you can see, there's a prefix im before the word mortal, which means not. So living forever, where mortal is not living forever, and immortal would be living forever. Long, long ago in ancient Greece, some people began telling stories to explain the mysteries of life. Over much time, the stories, or myths, grew rich and imaginative. The storytellers were woven in their customs, beliefs, and theories about life, death, and the wonders of nature. The myths were about gods and goddesses, fearful monsters, brave heroes, and mysterious beauties. People believed the myths were true. They worshipped the gods, who they believed helped and guided them, and built temples to honor them. According to the mythology, the gods and goddesses looked and acted human. They married each other, they laughed and loved, quarreled, and fought with each other. But they were immortals. They lived forever because a fluid called ichor, not blood, flowed through their veins. The mightiest of the gods and goddesses lived in a golden palace on Olympus, a mountain so high the top was hidden by clouds. They feasted on ambrosia and nectar, the food and drink of the gods. And whenever they wished, they could change the shape and speed down to earth to mingle with the mortals. The awesome Olympians earned their thrones on Olympus. They fought a fierce battle and won. This is the story of how it happened. It starts at the beginning of time. In the beginning, Gaia, the earth, grew out of a dark space named chaos. Gaia gave birth to Uranus, the sky. Uranus rained down on young Gaia, and plants, animals, and rivers appeared. Gaia became Mother Earth, mother of all living things, and mother of the first gods. Gaia and Uranus had many children. Their firstborn were 12 giant titans, 6 girls and 6 boys. Later, more children were born. 3 were the mighty Cyclops, strong one-eyed giants. 3 were the Hecatoncheirus, monsters each with 100 arms and 50 heads. Uranus hated the Cyclops and the Hecatoncheirus because they were ugly. He threw them into Tartarus, the deepest pit in the underworld. Gaia was furious. She urged the Titans to overthrow their father and rescue their brothers. Only the youngest, Cronus, was brave enough. He attacked Uranus with sickle and banished him from the earth. Cronus replaced his father as Lord of the universe, but he was cruel and did not free his brothers from Tartarus. Cronus married his sister, Rhea, and they had many children. But Cronus was afraid that one of them might overthrow him, just as he had overthrown his father. So, as each child was born, he swallowed it. Rhea was horrified. When the youngest was born, she tricked Cronus. She hid the baby Zeus in a distant cave so Cronus would not find him. Rhea then gave Cronus a stone wrapped in a blanket. He swallowed that instead, blanket and all. Hidden away, Zeus was raised by gentle woodland nymphs and a nymph goat named Amalthea, who fed him honeyed milk. When the baby cried, the Kratos and Zeus guards clashed their weapons to hide the sound. Zeus grew into the strongest of all the gods and married Metis, a Titan's daughter. Rhea was still angry with her husband and wanted Zeus to depose him. Remember, depose means to remove from office or position forcefully. But Metis, the goddess of prudence, was wise. She said Zeus needed help, for Cronus had Titans on his side. Rhea found a way. With her help, Metis gave Cronus a drink she promised would make him undefeatable. Word undefeatable, meaning not able to be beaten. Here's our prefix un and able, making this undefeatable. Instead, it made Cronus throw up the stone and his unharmed children, Hestia, Demeter, Hera, Hades, Poseidon. They were reunited, and gratefully they joined their brother. Zeus freed their uncles from Tartarus, and together they prepared to fight the Titans. The Cyclops, who were great builders and smiths, made the weapons. They armed Zeus with the thunderbolt that shook the universe. They made Poseidon a trident that could split the seas. They gave Hades a helmet of darkness that made him invisible to his enemies. For 10 years, war raged between the old gods and the new gods. At last, Cronus and the Titans were defeated and thrown into Tartarus, to be guarded forever by their 100-armed brothers. Mother Earth was finally at peace. Rule of the universe was divided among the three brothers. Zeus was declared king of the gods and god of heaven and earth. Poseidon became the god of the sea, and Hades, god of the underworld. The Cyclops built the victors a palace on Mount Olympus with 12 golden thrones inside. For Zeus shared his powers with his brothers, his sisters, six of his children, and Aphrodite, the goddess of love. There, the great Olympians lived forever. Zeus, king of the gods, god of heaven and earth, son of Cronus and Rhea. Zeus was everywhere, seen and unseen. He changed his shape as easily as he changed the weather. He moved the sun and the moon and put constellation in the sky. He protected everyone, gods and the mortals alike. In anger, Zeus hurled his thunderbolt to punish those who deserved it. But he was also wise and fair and generous with his praise. Zeus first married Metis, but he made Hera his queen. Zeus and Hera bickered constantly, for Zeus had many other wives, goddesses, nymphs, and mortals, and had many children too. Hera was jealous of them all. Hera, goddess of marriage and childbirth, daughter of Cronus and Rhea. Hera was beautiful and headstrong. Zeus won her when he turned himself into Cuckoo and he flew into her arms. Their wedding was so happy it lasted 300 years. But things changed. Though Hera helped and advised Zeus and bore him children, jealousy darkened her days. She hated her husband's adventures. She schemed against his many wives and children and caused them to hide in fear. Once, in anger, Hera even dared to steal Zeus's thunderbolt, but his temper was stronger. He hung her up from the sky with angels tied to her feet and freed her only when she repented. Hephaestus, god of fire and blacksmith, son of Zeus and Hera. Here's a couple of words for us. A brooch. It is an ornament fastened to a clothing with a pin. Lame, it means unable to walk. Hephaestus was born with bad luck. He was so weak and lame, Hera took one look at him and dropped him out of Olympus. He fell for a day and was rescued by the sea goddess Thetis and her sisters. They took him to their underground grotto, and there he lived in secret. Hephaestus' body grew strong, and though he could never walk, he became a master craftsman and made beautiful objects of gold in his smithy. Many he gave to the goddesses as thanks for their kindness. 9 years later, Hera saw Thetis wearing an exquisite brooch and demanded to know who made it. When Hera heard it was Hephaestus, she regretted her actions. She called him back to Olympus, allowed him to marry Aphrodite, and create an even bigger workshop for him. Hephaestus became the worker of the gods. He made them golden palaces, chariots, weapons, and tools. For himself, he invented 2 golden maidens who helped him move about. His artistry was the pride of Olympus. Poseidon, god of the sea and earthquakes, son of Cronus and Rhea. Poseidon was moody. His temper could be as violent as the seas he ruled. He shook his trident and leaping waves flooded the land. He struck the earth and mountains erupted. When he was calm, rivers dried and islands formed. Poseidon created the first horse from a rock with one blow. He raised the waves and traveled to Olympus in his golden horse-drawn chariot. Most of the time, Poseidon lived in a golden underwater palace with his queen, Aphrodite, a lovely sea goddess. They had 3 children together. Though Poseidon had many more, like Zeus, he could not resist goddesses, nymphs, or mortals. Let's revisit our learning target. I will learn what are myths in literature, success criteria. I can explain what myths are. I can read about gods and goddesses from the book, The Gods and Goddesses of Olympus. Can you explain what are myths in literature? Also, can you share 3 things about gods and goddesses that you read in this book? Great job, super job. Well, once again, thank you for reading with me. That was a lot of fun, and I hope this will continue to explore lots of different genres in literature. And don't forget, reading is awesome.
Thank you so much for joining me again. We have a lot to do today. We're going to cover multiplication and division, and I'd like to get right to it. Thanks for coming back. Do you realize how much we've learned so far? Oh my gosh. So let's cover what we went over last time. We have done place value with decimals, but we did addition and subtraction. So I feel like you did really well, but it's not like I really know. But this time we're going to go through division and multiplication. We're going to use those same skills we've been using with the decimal. So division, multiplication won't be too much different than what you already know about decimals and what you already know about those two operations. So let me show you some of the learning target and success criteria. Same learning target, I can multiply and divide decimals to the hundredths. And now this time we're going to use our prior knowledge, but then we're going to add on drawing concrete models to represent the equations, and we're going to be able to explain our reasoning for our answer. Okay, so we're going to multiply and divide. So these are some of the screens that I showed last time to really tell us what are decimals. Okay, so if you remember, we're going to be moving to the right of the decimal, and all of those are less than 1. So that's just a refresh from last time. So right now it's time to gather your supplies because we're going to get right into it. So paper, pencil, whiteboard, marker, eraser, same deal. If you're on TV, I'm giving a little bit of time. If you're on a computer, you'll be able to pause it. Either way, hopefully you're coming to our sessions with supplies. Okay, so I left you hanging. So here's a joke. What are 10 things you can always count on? What do you think? Your fingers. Okay, so that was the one I left you hanging with. Okay, 38 times 91 is 3,458. Just like when we were adding and subtracting, you already know how to do multiplication division with decimals. Okay, so we're going to take that same one, 3 and 8 tenths times 9 and 1 tenth is 34 and 58 tenths. And again, we're talking about two multiplication problems. So we have 1 tenth times 3 and 8 tenths, and then we have 9 times 3 and 8 tenths, right? So we have these two and they kind of go together. So this is a really good time to take a screenshot to remind yourself of how the multiplication goes. And again, we're using like place value as a foundation. Okay, so you might have noticed something. Why did multiply something behind the decimal make it smaller? Okay, so let's talk about that. We have 3 and 8 tenths, which is more than 1, and we have 1 tenth, which is less than 1. Okay, so that's the indicator right there. If you have 3 and 8 tenths, that's saying what is 1 tenth of 3 and 8 tenths. So let's remind ourselves with an area model. We have our 10 squares and we colored in 1, and that 1 in red is 1 whole. Okay, so 1 tenth of 3/8 was what we're figuring out. So here's kind of the multiplication rule for decimals. Okay, so we start with 1. To the left of the 1 is smaller, to the right of the 1 is bigger. So when you multiply by something smaller or less than 1, it'll get smaller. And if you multiply something more than 1, it'll get bigger. But that's only for multiplication. So take a screenshot for this, and we'll talk about division in just a moment. Okay, now here's the division rule for decimals. It's just going to be the opposite. Have we noticed a trend with multiplication and division? They're an inverse of one another. So when you divide something by less than 1, it'll actually get bigger. And when you divide something by more than 1, it'll get smaller. Okay, so that's for division. So you also maybe want to take a screenshot of this too to keep this in mind. Okay, so we're going to try and then we'll work it out, all right? So 27 and 6 tenths times 3 and 9 tenths. I'm going to give you a good chunk of time like I always do. Now you might be wondering, what am I doing with the decimals? This is either review for you or this is brand new to you. And if it's brand new to you, do the multiplication problem and we'll talk about the decimals afterwards. If this is review, I didn't want to give it away in the beginning. What do you do with the decimals, okay? So spoiler alert, we're coming right up on this, okay? So 27 6/10 goes to 28, right? If we're estimating, and 3 9/10 goes to 4. So we're trying to figure out 3 times 4, 120, or if you want to get really jazzy with it, 4 times 2 is 8. So you take the 8 away because that would be 28. And then you have 112. So now you're solving your equation, but just like before, we are making sure that the decimals make sense. So we have 2 decimals on the right there. So we're going to need 2 decimals in our product. Okay, so we have the 9/10 and the 6/10, and that means that we have to have 2 numbers behind the decimal. So if you notice the math that I've been doing here, I've been doing our standard multiplication, but the only difference is we have that. So we have 107 64 hundredths. Okay, so now let's try another one. Okay, so don't forget to line up the decimal. Remember, we have 6/10 and 3/10 behind the decimal. So we'll have 2 behind the decimal. First, what's your estimate based on rounding? Because we want to start with that when we're doing these. Okay, so 64 3/10 rounds to 64, and 4 6/10 rounds to 5. You can either do 60 times 5 plus 4 times 5, which is 320, or you can just plain do 60 times 5 is 300. Because 4 6/10 is a little bit more than 4, we might end up closer to 300 anyway. Okay, so I've lined up that for you. Now you're going to do the multiplication problem. Now remember, if you have 2 numbers behind the 2 decimals, that means you're going to go to the hundredths place in your product, in your answer. And again, just take it slow, do multiplication like you know how to do, and then think about the decimals, right? And we've been talking about that, and we'll keep talking about it, so don't worry about it. All right, so spoiler alert, it's coming up now. Let's work it out. So your total answer should be 295 78 hundredths. Okay, so we're really paying attention to the 2 spots to the right of the decimal. This is building on what you've already learned in previous videos. So now I'm going to look, is 295 similar to 300 and 320? Yes, it is. So I did get a reasonable answer. Okay, let's go back to our success criteria. So we're going to start talking about the concrete models now. Now, you might be familiar with hundreds frame, but it also goes to hundredths frame. So let's take a look right now. A hundreds frame is 10, 20, 30, 40, goes up to 100, okay? And it's 10 out of 100 is 1 line. Now, what we're going to do is kind of push that over, and a way a model can be is now it's in tenths, and 1 line is 1/10. And 1/10 is 1/10 of 1. So now this hundredths frame is 1 as a whole. Okay, so we're going to keep that in mind when we're building our models for our number. So let's look at 4 6/10. We have 1, 2, 3, 4, 5 hundredths models, and then we're going to color in completely 4 of them. And then what are we going to do with the last one? We're going to color in 6 of the columns. Instead of it being 5, we only went to 6/10. Okay, this is a good time to also take a screenshot so you can remember kind of how these concrete models go. And we're going to be able to explain our reasoning for our answer, but we haven't done that yet, so don't worry. Right now, what we've done is multiplied our place value, and we're kind of thinking about, okay, how do these decimals line up? We're working with tenths a lot more, okay? So I want to know, how are you feeling? If you've watched my other videos, you know how this goes. So 1 means you don't get it at all, 5 means you get to teach it to somebody else, and 2, 3, 4, somewhere in between with your understanding. Okay, why are parallel lines so tragic if they have so much in common? Now, parallel lines are two lines that it's a shame they'll never meet. Parallel lines are two lines that will never meet on a coordinate plane. You'll learn that in 6th grade, no worries. Okay, let's solve a problem and then explain our reasoning. So you're going to solve the problem first, and then we'll explain together. So don't worry about that. So what you want to do is set up your problem, make your estimates, make sure your decimals are lined up, all those things. If you notice, we're only going to tenths. So we have two different numbers with tenths. So that means we're going to go to the hundredths in our product because we'll have two numbers to the right of the decimal. So right now you're solving, don't worry about explaining your reasoning. We will do that together. All right, so spoiler alert, it's coming up. So what we did was 62 and 4 tenths times 2 and 7 tenths is 168 and 48 hundredths. So if you got that, nice job. Now let's explain our reasoning. I was able to determine the product is, that's a really good way to start. So you're going to leave that and put your product, which is your answer, 168 and 48 hundredths, because I took the multiplicand, multiplicand of 62 and 4 tenths and the multiplier of 2 and 7 tenths and multiplied them together using the standard algorithm. Now we want to add a little bit more because you've been using estimation. So I knew that the answer was reasonable because I rounded both numbers to get a similar product as the final answer. So this is a really good time to take a screenshot because I'm going to want you to use these sentence stems later on in like the next question we're about to do. Okay. So take a good screenshot or cell phone picture. Okay. So we've been talking about multiplication, division in relation to one another. So remember, if you divide by something more than one, it gets smaller, and you divide by something less than one, it gets bigger. So keep that in mind, and you're adding that to your schema. Okay. So we're going to put it all together. Step 1, we're going to use our prior knowledge from all the anchor charts you've been doing. 2, we're going to use estimation to predict our answers. 3, you're going to use multiplication to check your answer when finished. And then 4, you're going to explain your reasoning for your answer. Now, I have to tell you something first. You want to make the number on the left a whole number. So you're moving a decimal over. So 1 6 tenths becomes 16, and 93 and 92 hundredths becomes 939 and 2 tenths because we're making the number on the left a whole number. So that is your equation. 16 divided by 939 and 2 tenths, and you have 2 full minutes to complete the whole thing. Okay, so use your prior knowledge, do that estimation first, use multiplication to check your answer when you're done, and then explain your reasoning. You have a really big chunk of time, so no worries. All right, spoiler alert. So let's talk about it. We're going to use our prior knowledge. So I'm thinking to myself, okay, what do I know about division? Something that was just told to me is I know that I'm not dividing by a number less than 1. So my product will be smaller than my dividend. So that's one thing I know. Now I'm going to estimate using rounding. So 1 and 6 tenths rounds to 2, and 93 and 92 hundredths rounds to 90. Yeah, so 90 divided by 2, or actually 1/2 of 90 is 45. So for my answer to be reasonable, it needs to be near 45. Okay. And there's a couple ways to write it. So I just want to make sure that we show those visuals so you understand what we're working with. Okay. Then the third one, we want to solve our actual equation. So again, I'm moving the decimal, I'm moving it over. That way we're dealing with a whole number on the left. So 16 goes into 93 5 times. 93 minus 80 is 13. You bring down the 9. Now, how many times does 16 go into 139? That involves some math. 8 times. 8 times 16 is 128. Now you bring, you subtract that 11, and then you bring a 2 down. Now, what can you use that you just did to find out how many times 16 goes in 112, right? You just did the 8, so try 7. Oh, yeah, 7 goes, 16 times 7 is 112. So you got your even number, right? So now let's explain it. Here is exactly what I wrote before. So I want you to continue to use this to explain. So I was able to determine the product. I took the multiplicand. It's a difficult word to say. And, you're explaining that you rounded. This is a really good way to do this, okay? How do you feel? Okay, so let's go back over. I'll multiply and divide decimals by using strategies you previously used, drew concrete models, and explained it. So 1 to 5. Okay, now last joke. Nah, I didn't want to do a joke. I wanted to congratulate you. You're doing so amazing. I'm so proud of all the work you've been doing. Woohoo! Like I said, congratulations. You've done an excellent job at figuring out how to use math to understand life. Okay. There's so much to learn. There's so many other videos out there. Use the internet for, good, right? So it's not just about Fortnite, it's about making sure that we understand how to live in our world. So if you need to review anything, hopefully you have access to these videos and you can take screenshots, but there are also lots and lots of resources out there. And don't forget to talk to your family. All right. Well, you have an excellent time, and I will see you next time. Bye.
Hola chicos, buenos días. Hoy vamos a hablar de decimales otra vez. Si has visto los videos anteriores, estuvimos hablando de decimales. Vamos a seguir con el mismo tema, pero hoy vamos a hablar de cómo dividir decimales, ¿ok? Es igual que dividir cualquier otro número, nada más tiene un decimal, ¿ok? Vamos a ver varias estrategias, y ustedes pueden escoger tu favorito, ¿ok? Entonces, que tengan un papel, un cuaderno, algo con que puedes escribir, y ya vamos a empezar. Ahorita con problema de división, como siempre, les voy a mostrar unos 3 o 4 maneras o formas en que puedes resolver esos problemas y luego ustedes pueden escoger el que sirve mejor para ti, o tal vez por un problema va a funcionar una estrategia mejor que otro y puedes usar eso. O sea, les voy a dar varias maneras de resolver problemas de división de decimales, ¿ok? O con decimales. Entonces vamos a empezar con aquí. Tenemos un maestro Kovich, prepara materiales para un proyecto de manualidades. Necesita cortar 2 metros de cuerda en trozos que midan 2 décimos metros de largo. ¿Cuántos trozos de 2 décimos metros puede cortar de una cuerda que mide 2 metros? Ok, vamos a ver lo importante aquí. Ya sabemos que es división porque ya les dije, ¿verdad? Tenemos una cuerda de 2 metros, ¿ok? Necesitamos 2 décimos metros, ¿ok? Pedazos o trozos que midan 2 décimos de metros. ¿Cuántos trozos de 2 décimos de metros puede cortar de una cuerda que mide 2 metros? ¿Ok? Ustedes tal vez ahorita están diciendo que pues ya sé. ¿Ok? Nada más hay que cambiar la posición de uno de los decimales y ya está. Wow, impresionante, ¿ok? Por eso es muy importante que ustedes sepan cómo es el valor posicional de los decimales, ¿ok? Es muy importante. Y si no sabes cómo es, está bien. Puedes ir a Google y puedes buscar valor posicional de decimales, ¿ok? Y va a aparecer algo que les va a mostrar cómo es de décimos, centésimos, milésimos, ¿ok? Unidades, vas a tener tu decimal ahí, ¿ok? Pero eso es bien importante. Entonces, si estás un poquito confundido con eso, ve a Google, busca valor posicional de decimales, ¿ok? Muy bien, chicos, entonces vamos a empezar con ese problema. Lo que vamos a hacer ahorita es, vamos a hacer una recta numérica, ¿ok? Vamos a usar una recta numérica para resolver ese problema, ¿ok? Vamos a ver ahí está, nuestra recta numérica ya hecha, qué bonito, ¿ok? Es nuestra cuerda, ¿verdad? Mide 2 metros, aquí tenemos el 2, ¿sí? Obviamente aquí falta 0, ¿sí? Wow. Falta nuestro 0 ahí. Oh, tiene que ser perfecto, ¿verdad? Ok. Un 0. Ok. Muy bien. Vamos a ir contando que midan 2 metros. Si te fijas aquí tenemos un 2 ahí. Ok. 2 décimos. Estamos contando por 2. Ok. 2 décimos. Y aquí tenemos un entero. Entonces vamos a ir contando. 1, 2, 3, 4, 5. Y ya llegamos a 1. ¿Verdad que sí? Ok. Y luego vamos a ir brincando. 1, 2, 3, 4, 5. Entonces tenemos 5 aquí. 5 aquí. Entonces 5 más 5. En total podemos hacer 10 pedacitos. ¿Verdad que sí? Podemos hacer 10 pedacitos. ¿Ok? Entonces eso es nuestra respuesta, ¿sí? ¿Cuántos trozos de 2 metros puede cortar de una cuerda que mide 2 metros? Pues 10, ¿verdad? Cuando estaba hablando de nada más tenemos que cambiar la posición de nuestro decimal. Fíjense aquí, 2 décimos, ¿verdad? Vamos a cambiarlo. Y ahora mide 2 metros, ¿verdad? Lo cambiamos, y así es como sabemos que sería 10, porque estamos yendo de 10 décimos a 2, ¿verdad? O sea, vamos de décimos a 2. Es igual que hablando de valor posicional de unidades, o sea, vamos de 1 a 10, ¿verdad? Entonces tenemos 10 partes. O sea, si estamos hablando de 10, tenemos 10 partes de 1. Entonces, si estamos hablando de décimos, tenemos 10 décimos que se hace 1, ¿ok? Valor posicional, chicos, muy importante, ¿ok? Es lo más importante de todo eso, es valor posicional de decimales, ¿ok? Pero me gustó eso, hacer un dibujo, una recta numérica, eso me ayudó a ver cómo resolver ese problema. ¿Ok? Muy bien. Entonces podemos hacer 10 trozos de 2 décimos metros. ¿Ok? Ir contando. Vamos a ver otra manera. Puedes buscar patrones en la división, es mate, patrones, sí, lo más importante para ver en qué se parece y en qué se diferencia dividir con números enteros. ¿Cuántos grupos de 2 hay en 2? Y eso es lo que estuvimos hablando. O sea, ¿cuántos grupos de 2 hay en 2? 2 entre 2. Pues es 1, ¿verdad? ¿Cuántos grupos de 2 décimos hay en 2? Bueno, acabamos de decir, ¿no? 10. ¿Y cuántos grupos de 2 centésimos? Ahí está la respuesta, ¿ok? En el nombre del valor posicional. Aquí es décimos, 10. Centésimos, ¿cuántos va a haber? Eso. Muy bonito, ¿verdad? 100, ¿ok? Igual aquí. Para completar las ecuaciones, eso va a ser 1, 2 entre 2, 2 entre 2 décimos va a ser 10, ¿verdad? Y luego entre, o sea, centésimos, 100, ¿ok? Valor posicional, chicos. Todo es valor posicional. Vamos a ver otro problema, ¿ok? La entrenadora Ann prepara una carrera de 2,7 kilómetros. Usa banderas para marcar 9 secciones igualitos de la carrera. ¿A qué distancia debería colocar las banderas para marcar las secciones? Ok, imagínate, tú estás corriendo, ok, quieres ver que es igual cada sección de la carrera, ¿verdad que sí? Que no quiero que uno esté más largo que otro, o sea, no vas a poder salir bien, ok, tiene que mantener el mismo paso, entonces es muy importante eso. Entonces, aquí, ¿qué tenemos? ¿Qué es eso? ¿Qué se representa aquí? Ve, 2,7 kilómetros, ¿verdad? Aquí hay 1, 2, y luego 1, 2, 3, 4, 5, 6, 7. Ok. No vamos a usar nuestra línea numérica ahorita. Se puede, pero les voy a mostrar otra forma de resolver ese problema, ¿ok? Lo que tenemos que hacer es dividir, ¿verdad? En partes iguales. Aquí tenemos un entero, ¿sí? Y aquí tenemos las rayitas, ¿ok? Las barras son los décimos, ¿sí? Entonces sí, tenemos 2,7, ¿ok? Vamos a deshacer esos números enteros, el 1 y el 2. ¿Cuántos décimos hay? ¿Cuántos décimos hay en el 1 y en el 2? ¿Cuántos décimos? ¿Cuántos décimos hay? Eso es porque es muy importante tu valor posicional, chicos. ¿Cuántos décimos hay en un entero? 10. Muy bien. Entonces podemos hacer, o sea, 10 rayitas. Yo no voy a intentar hacerlo porque va a salir todo feo. Pero sabemos que hay 10, ¿verdad? Hay 10 barras. Ok, 1, 2, etcétera, etcétera. Igual aquí. Entonces, al final de cuentas, ¿cuántas barras vamos a tener? ¿Cuántas vamos a tener en total? Pues 27, ¿verdad? ¿Por qué 2,7 kilómetros es igual a 27 décimos? ¿Ok? Entonces, ya que dibujamos, ustedes pueden estar dibujando ahí en sus cuadernos las barritas. Debemos de tener 27 y podemos agruparlos, o sea, algo parecido a eso. Y tenemos 1, 2, vamos a hacer eso. Vamos a poner eso aquí arriba para que podamos ver la pregunta. ¿Ok? Y ahorita, ¿cuántos grupos tengo? O sea, es igual cada grupito, ¿verdad? el círculo, o sea, está diciendo que eso es un grupo, ¿ok? Es un grupo de 3. Un grupo de 3. 2 de 3. 3, 4, 5, 6, 7, 8, 9. ¿Ok? 9 secciones iguales de la carrera. ¿Ok? Eso nos decía. Entonces, ¿cuál es mi respuesta? ¿A qué distancia debería colocar las banderas para marcar las secciones? Pues a cada cuánto, a cada que se representa una barra era un décimo, ¿verdad? Entonces, 3 barras sería 3 décimos, chicos. 3 décimos, ¿sale? ¿Ok? Les voy a mostrar algo, ¿ok? Que funciona con ese problemita, ¿ok? Va a ser un poquito diferente si tienes 2 decimales, pero como solo tenemos un decimal, vamos a hacerlo así, ¿verdad? Ustedes ya están en quinto, ya saben cómo dividir así. ¿Ok? Es 9, ¿ok? Entre 2 y 7 décimos, ¿sale? Es 9 entre 27. ¿Cuántas veces va 9 entre 27? Pues ustedes saben que eso sería 3, ¿verdad que sí? El truco aquí, si estás dividiendo y si tienes un decimal aquí, nada más tienes que subir tu decimal y ya está la respuesta, ¿ok? No tiene que dibujar ni nada. Si ustedes saben ya cómo dividir, nada más tiene que escribir, o sea, poner el decimal ahí. Tiene que ser en una fila, ¿verdad? En una fila. Pero, o sea, va a ser diferente si tienes un decimal aquí afuera, ¿ok? Entonces, eso solo funciona si tienes el decimal aquí adentro de la casita, se dice, ¿no? Ok, muy bien, un truco ahí, un poquito más fácil. Y puedes otra vez usar tu cerebro para ver que, bueno, pues 3 décimos, o sea, por 9, sí tiene sentido, ¿ok? Sí tiene sentido. Vamos a ver. Aquí es como se puede hacerlo con un diagrama de barras para representar el problema, ¿ok? El número de grupos iguales, lo que no conocemos es el número de kilómetros que hay en cada grupo. Ahora sí, ¿ok? Ahora sí. También un poquito de álgebra, ¿ok? Como ustedes son muy inteligentes, ¿verdad? Hmm, 2 y 7 decimos entre 9 es igual a K, kilómetros, ¿no? Entonces, 9 por K es igual a 2 y 7 décimos. Ustedes ya saben, eso es como puedes verificar tu respuesta, ¿sí? Con multiplicación. Entonces, si ponemos aquí, en vez del K, si ponemos el 3 décimos, vamos a tener la misma respuesta. Entonces, sí es correcta la respuesta de 3 décimos, ¿ok? Bueno, eso se ve un poquito confuso al principio, ¿ok? Pero nada más es otra forma de dividir, ¿ok, chicos? Jaime, o Jamie, tiene 5 frascos para llenarlos con cuentas para un juego de feria. Tiene 7 y 5 décimos bolsas de cuentas de varios colores. Jamie quiere colocar la misma cantidad de cuentas en cada frasco. ¿Cuántas bolsas de cuentas puede colocar en cada frasco? Usa cuadrículas decimales para resolver el problema. Explica tu solución. Tenemos 10 aquí. ¿Okay? No te preocupes con eso. Cada uno de esos, o sea, tiene 100 partes, ¿verdad? Entonces, cada cuadrito aquí es un centésimo, ¿verdad? Y cada barra aquí es un décimo y el cuadro es un entero. ¿Sale? Y vale. Listo, chicos. Vamos. Ok. Tenemos 5 frascos y vamos a llenarlos con cuentas. Tenemos 7 y 5 décimos de bolsas. Entonces lo que yo voy a hacer es voy a contar 1, 2, 3, 4, 5, 6, 7 y 5 décimos, ¿verdad? Entonces, todo eso aquí, ¿ok? Representa mis bolsas de cuentas, ¿ok? Ahorita lo que vamos a hacer es vamos a dividir esas bolsas en 5 frascos. Lo que puedo hacer es 1, ¿ok? Aquí. Ok, 1.5, ¿no? 1 y 5 décimos. Y vamos a hacer lo mismo aquí. Y luego voy a hacer lo mismo aquí. Ok. Y luego aquí. Y luego uno más. Entonces aquí tengo 1, 2, 3, 4, 5 frascos llenos. Ok. 5 frascos que puedo usar. Ok. 5 frascos. Y ahora dice, usa la multiplicación para comprobar tu respuesta. Entonces, ¿cómo lo hacemos? Vamos a hacer 5 por 1 y 5 décimos es igual a... hay que hacerlo tú, chicos. Puedes ir contando, o sea, obviamente ahí está, es igual a 7 y 5 décimos. Entonces, sí tiene sentido la respuesta. Ok, chicos, es otra manera de hacerlo con multiplicación. Les voy a dejar con ese problemita. Puedes usar estimación, puedes poner pausa, chicos. Ok, y intentar resolver ese problema solitos. Adiós, chicos, que les vaya bien. Hasta la próxima vez.